of Advent of Code 2021. Let the stream begin. Test 1, 2, 3. Okay. We got good AV sync going. All right. I got 20 minutes to prepare for people to kind of migrate into the channel who kind of want to watch. So I think I'm going to get set up for day 11. Then if I have a lot of spare time, maybe clean up the encode module I made the other day. This one. Remember encode from 2019? Okay, so day 11. Oh, I guess day 10 got sorted between day 1 and day 2. I guess I'm okay with that. That's okay. Let's get benchmark set up for it. Hey there, Egoist. How are you doing this evening, this morning, middle of the day, middle of the night? Whatever time zone you're in, how are you doing? I'm just getting set up. Got 19 minutes to go before day 11 starts, so I don't waste any time like stripping out old code. I'm just getting this all set up to go. Some big fat to-dos here. I should turn off emote only chat. Sorry about that. I turn on emote only chat when I am not streaming so that I don't get hit with a bot or something while I'm not streaming and then get flagged for not moderating my chat. Doing pretty well, except for forgetting to turn off emote only mode. I didn't need to copy that file. How about we'll just delete the contents and then call it 11. All right. Why is this still a warning? Or an error? Okay. Then like, do I need to save it again? So cargo run 11.1 should run something. Should just crash saying not implemented. Unknown puzzle. Okay, I missed a step. I missed a step in main. Yep, missed a step. Maybe next year I'll use a real framework for so I don't have to hand code that. But it's sort of like warm up to like be typing this like mindless copy pasted framework code just to get set up. I don't know. There's something like good about doing a mindless activity while you're warming up to do something that's going to require brain power. So let's see how much time we have. So 17 minutes. So Advent of Code is an event that happens every year since I think around 2015. Yeah. And it's during the month of December. So like an Advent calendar, you get something every day from day 1 to day 25, so of December. And in this case, it's 2 programming puzzles, and they're Christmas themed. They're very corny, usually. Either about elves or about Santa. This year, we're under the ocean. That's the ocean on day 1. We dropped Santa's sleigh's keys into the ocean. Oops. So to save Christmas, we gotta go find the keys. So of course we have a submarine to go under the ocean, look for those keys. So we've encountered all sorts of things at the bottom of the sea, and then we found this underground cavern, and I think that's where we still are on day 11. Sometimes the puzzles of the day don't really make sense. Other times they fit with the theme. Usually it's just loosely associated with the theme, and they're pretty contrived, but they're kind of fun. So 15 minutes to go. I'll just go over what yesterday's was. So they begin with something that related to the theme. They're like, we need to get out of this deep sea cave to determine the best route. You ask the submarine, and it says syntax error, navigation system, all of the lines of the navigation system, and then it proceeds into, well, it's not really a navigation system. It's just a bunch of punctuation, and the task is to like find all the syntax errors. So that was kind of fun. I used a stack to solve that. So go over that solution again, because why not? I got some time to kill. Maybe I'll find something I can clean up here. So my solutions are all in Rust last year and this year. If the syntax looks a little funny, it might be because you don't know Rust, but maybe you know a different language like JavaScript, Java, C, C++, C#. They're all kind of similar. You could probably, if you learn one language, you can probably get the gist of any of these other languages. So in this case, we're taking an input string that looks like, something like this. Actually, what's a better example? Yeah, here we go. That example. We're taking that and then cutting it into lines. And then for each line, we're making a vector of delimiters. Then we're taking that line, trimming off the white space, cutting it into individual characters. And then for each character, we're going to find, and then if we do find, map the character to a score. So part one is about finding the mismatched delimiters, right? So if we find the beginning delimiter, we push onto our stack. But I chose to push the matching close delimiter onto the stack for a reason, and that's for this one. If we find a character that's not an opening delimiter, it's either an error or it's a closed delimiter. And if it's a closed delimiter, if the last one that we push on the stack is what we expect, then we just pop it off, no big deal. But if it doesn't match, then we found the syntax error, and then we turn that into a number of points that comes out of the find map. If we fall out, meaning we go through all the characters, we don't find any errors, it's a score of 0. And we count up all the scores and then convert that to a string, and that's the output. So this test right here took that same example here because they told us what it should add up to down here, to 26,397. So we put that number here and just made a test that made sure that our solution gets the same answer. So part two was about finding the lines that everything does match, but then but are incomplete. So for example, these are the 5 lines from the example that are complete if you add these missing characters at the end, right? So it's a little bit different. We toss the lines out that have syntax errors, and the incomplete lines, we figure out the score based off of what we would need to add to complete the syntax, and then use this little set of instructions on computing the answer. And they say, well, you should get 288,957. So we put that in for test part 2, that number. Same input, and the solution looks sort of the same to begin with. We take our input, we cut it into lines, and for each line, we have a stack of delimiters. Opening delimiter, we push the closing one. The closing one, we just pop off the delimiter. Here's where it's different. So if we get an unexpected end delimiter, one that doesn't match, then we don't have any score because we're supposed to toss those lines that are syntax errors, right? So we only fall out if we get a line that doesn't have syntax errors. So we're going to assume we're going to have some leftover characters in the delimiters. If we don't, we're just going to have 0 as the default score. Turns out that never happens, but it's sort of a nice thing. One of the viewers yesterday recommended I do it this way, and I totally agree with him. So even though we don't hit that, it's kind of a clean way to handle it if we were to have hit that. Anyway, for every delimiter we pop off, multiply the score by 5, add in a number based off of which delimiter it is, loop until we're done, and that's the score. This flatten removes the nones that we might have had and strips off the sums. And then this part I messed up at first. I didn't have this part. They had some extra instructions here. They say once you get the points, you sort all those points and you take the middle one, and there'll always be an odd one, so you know which one is the middle, right? And so we have to collect all of those scores into a vector, then sort the vector, and then pick the one out of the middle. That's what that's doing. All right, so I got 11 minutes. Anybody who's watching, please feel free to ask questions. I'm going to go over to this routine I used to get the Easter egg from day 7. It's code I ported from a 2019 Advent of Code puzzle. It's called the int code compiler. So if you did 2019 puzzles, you'll know that there's like an int code compiler, basically a mini computer, a very, very small computer with a very, very small instruction set that you built up from each day. Hey there, Musin. To rewrite that while let sum with an iterator, vectrain, reverse, then fold. Yeah, I thought about doing the fold to do that, accumulate the scores as a base 5 number, but I didn't feel like reversing the vector. That felt icky to me, you know? I'm already having to collect it, then to reverse it, only to avoid having to have extra semicolon. I guess it's here. You still need that extra semicolon, right? Yeah, even the great Musin has a semicolon in that answer. Actually, so Musin, the challenge is remove that semicolon from this line. There's a way to do that, right? Wouldn't we fold in the fold? Wouldn't we just say A equals A times 5 plus? Yeah, you just said it. Okay, good. How dare you write a semicolon? Doesn't move the allocation around or anything, but it does do a bunch of memory swapping. It felt icky. I didn't like having to collect in the first place, but I couldn't think of a way to sort them in place conveniently. I guess the way we could do it is, I was going to say, like, form a tree as we're iterating, but even that, like, don't you have to move things around? You have to look at the previous state. I guess you do it with the fold, and you'd in-place sort somehow, knowing how many lines there are, probably, right? Something like that. You'd have to do something where you in-place sort. It's a double-ended iterator? Yeah, because it's a vector, yeah. Oh, it doesn't? It just picks them in reverse order? Oh, that's clever. Well then, okay, I guess I'm okay with reverse for a vector. Okay. I take back my revulsion of reverse. So, day 7 had its own solution. It was based off of lining crabs up. So, ironic that we're doing it in Rust. So the example was you start with a bunch of crabs that are on these positions along a line, and since they can only move horizontally, you have to line them up by doing the minimal number of moves. And the clever solution, if you're a mathematician, is you're trying to find the median. I didn't know that. So anyway, long story short, solved that. Then someone on the internet had noticed that the beginning numbers of everyone's day 7 input is actually an encode program from EvinCode 2019. And so I dug up my encode processor, it's in C++, ported it to Rust, ran it on this. After I fixed a few bugs, found out that it does indeed print a secret message, and I'll show you what that is right now. 7 Easter egg. It says, "Ceci n'est pas un encode program." Of course, there's a typo here. Program in French is P-R-O-G-R-A-M-M-E, but that's okay. It's pretty cool that it prints out a secret message. So, but I didn't really get a whole lot of time to clean up my encode port. And one of the things I wanted to try to do with this is to change the run routine so that it does not allocate memory. So right now it allocates memory because it forms all the output and then dumps it all out in one shot. I thought that if we converted this to return an iterator, then every time the iterator is called to do next, it would just run the machine until the next output and then return that, so we don't actually have to allocate memory for the output in this routine itself. So to do that, I need to make an iterator type that can encapsulate our self and remember what opcode, what position we're at. I guess then I'd be pulling the position out of self. I wouldn't even need to pull it out. I could just leave it in there. I could just have an iterator that just encapsulates the encode thing and just calls run until it halts. Reverse will do a binary style. That's what I confused it with, I think, is it would swap it, yeah. But rev on an iterator, I can see your point where it just reverses the iteration order and not the actual memory contents. Yeah, I agree. Just didn't think about that. Or I guess I got it confused with the reverse. Rev reverse starts with the same 3 characters. I think I could be given some pass for confusing them. Okay, so the first thing to change this would be to make a new type. Where to put the type? Maybe after here. Struct. Does it need to be public? I don't think it does. We're going to call it int code run. Encode run. And we're going to implement iterator for encode run. Expand that. The item is going to be whatever the oops, I didn't mean to open that. Whatever the run function returns. iSize. So item is iSize. And we're going to encapsulate a borrow of the int code. So yeah, I know what to type here. It's int code borrow when we need some lifetime of int code. So that means there and there we'll need to reference that lifetime. The structure becomes generic over the lifetime of the borrow of this encode processor. So, in other words, we don't know what the lifetime actually is until something instantiates encode run, and then we know the lifetime at that point because we know how long the reference that it gives to initialize encode has to be valid for. So yeah, I guess I could just move the entire run into that then, or the contents of it in there, without the output, because that's the whole thing we're trying to get rid of. So I cut that code out, and I'm going to paste it down here and save. And then we're going to turn the run into returning the implementation of an iterator where the item is an iSize. And it has the same lifetime as the input. So instead of doing an output, we'll just do int code run. I don't even need to make it a struct. I mean, I don't even need to give it a name, right? I'll give it a name. I like giving them names. I could do the tuple version, which is this. I don't even, do I need that at all? I forget. Anyway, but I prefer giving it a name. I don't know why. Int code is self. I'm pretty sure I do need that, right? If I don't, it's going to complain, yeah, that the lifetimes don't match. You get like a semi-obscure error about that. Okay, I'm not going to be able to finish this on time because guess what? Day 11 is starting soon. I'm looking off to the side and I see that we are approaching the 2-minute mark. And encode VM, yes. The aneurysm, did you know day 7 has an Easter egg in it? Finally got your Rust impl working the other day. Use it on day 7 input and you'll see the secret message. Okay, I'm debating whether or not to do a minute's worth of work here and risk. Yeah, we can risk it. Yeah, day 7 of this year. Yeah, I'm not going to spoil it for you, but there is a secret message in the input. As for turning that into an iterator, you can just use from iter and move self. Yeah, but I thought we don't really need to. Actually, this is going to need to borrow self. Maybe you're right, because if I'm borrowing self mutably, why not just consume self, right? But it continues the spirit of run where it just borrowed mutably. It didn't consume self, you know? So you can like theoretically run it again. And then if I to truly make it run again, I could move out the things from encode that are different for every run, which would be the input and the position, and maybe original ROM of the code, you know, and then run could just borrow it immutably, and then you can run it multiple times for different input, right? So that was my train of thought, I guess. cheap way of not changing mute self is to do whatever mute self. Oh. Right, so it doesn't hold on to self, it just uses self. Sure. All right, anyway, we got 10 seconds left. So let's get set. I need to be on day 11. Here we go. This is where we're going to be editing stuff. 3 seconds to go. Good luck, everybody who's doing this with me. Here we go. Day 11, Dumbo Octopus. You enter a large cavern full of rare, bioluminescent Dumbo octopuses. They seem to not like the Christmas lights in your submarine, so you turn them off for now. There are 100 octopuses. Is an octopi arranged neatly in a 10 by 10 grid. Each octopus slowly gains energy. Over time flashes brightly for a moment when its energy is full, although your lights are off. Maybe you could navigate through the cave without disturbing the octopuses. If you could predict when the flashes of light will happen. Each octopus has an energy level. Your submarine can remotely measure the energy level of each octopus, for example. So when they say for example, this year's been pretty consistent. Most of the time it is something I can use for a unit test. So that's what I'm going to do right here. The energy level of each octopus is level between 0 and 9. Here the top left is 5, etc. You can model the energy levels in steps during a single step. Here are the rules. Increase by 1. Then any octopus energy level greater than 9 flashes. This increases the energy level of all adjacent ones by 1, including ones that are diagonal. If this causes an octopus to have energy level greater than 9, it also flashes. This process continues as long as new octopuses keep having the energy level increase beyond 9. An octopus can only flash at most once per step. Okay. Finally, any octopus that flashed during the step has its energy level set to 0, and it used all its energy to flash. So isn't that the same kind of a flood fill as we did for day 7 or 6? I can't remember which day. Adjacent flashes can cause an octopus to flash on a step, even if it begins that step with very little energy. Yep. So it could basically chain, right? This goes one step and then wait a minute. Oh, I thought they were going to show an example of this. An octopus is highlighted when it flashed during its given step. Here's a larger example of the above progresses. After one step, after 2 steps, a whole bunch of them flash, and then a whole bunch more. A whole bunch more. Okay. Oh, thank you. I got a milkshake. Is that milkshake going to be what I get to drink as a reward if I finish this? After step 10, there have been a total of 204 flashes. Fast forwarding, here's the same configuration every 10 steps. After 100 steps, okay, so this is the example. When they highlight it and put it in a little box, that's what we're looking for, right? And the 100 is significant, so that's going to be like the number of steps we need to run, right? Yeah. So, const, this doesn't need to be pub. We only did that for one of the days, and I've been copying it ever since. 100 steps, right? Given the starting energy levels of Dumbo octopuses in your cavern, simulate 100 steps, how many total flash? Okay, so we need to just count the flashes. So I'm just going to do an easy approach and not try to be clever, which is we're going to let, I don't know, grid. We're going to be able to mutate it. Equals input.lines.map line. Let me turn off the inlay hints for a second. Line.trim dot cares dot collect into a vector, and then again collect. So it's a vector of vectors of unknowns. It's unknowns because I have a couple syntax errors. And also, we didn't have a to-do here. It's still unknown. Why is it unknown? Shouldn't it be characters? Oh, it's probably because of this. Oh, I messed with the wrong lines. Fix it. Just part 1 inner. Fixed. Right, vector of vectors of characters, right? So then we're going to say for something in 0 to steps. And then at the end, I guess we'll accumulate flashes. It's just going to be flashes to string, right? And then simulating for every step. I think what we'll do is we'll run through the grid. Where's my beginning grid example? We'll run through the grid and we'll just increment. And if any 9, if we see any 9, it'll go to 0, and then we'll add that to a list of values that we're going to then flood. Yeah. So let mute boundary equals vec_new. Yeah, hey there, user 335. How are you doing? We're doing Advent of Code 2021 today. Hey there, Rabbit. XXXX. User 335. Advent of Code. It's an Advent calendar of programming puzzles. I like programming puzzles. You can do them in any language. I'm doing them in Rust. This is what Rust looks like. It kind of looks like C, C++, C#, Java, any one of those languages, only a little bit different. Hopefully, if you know any of those other languages and you look at this, it'll look really weird, but you maybe can get the gist of some of the things I'm doing. Like trim, I can tell you it just trims off white space. Chars takes a string and pulls apart each character and gives them to you one at a time. And collect takes a list of things and stores them into a vector, a vec. And the fact that I had an inner and an outer kind of tells you with these inlay hints that it's a vector of vectors of characters, which is modeling our puzzle for 11, which is to take in a grid of numbers and then do some processing over them. And through some rules that are explained here in the text, we're counting the number of times a number rolls over to 0 and getting a number as an output. So like I have a unit test that will check to make sure I did it correctly, but I take what they said what we should get given a certain starting point, and rolling it 100 times, what should we get? So if I do my code right, I run my unit test, it'll pass, and then I can do it with the real puzzle input, which is a different grid, which I might as well just collect right now and put in so I don't forget. And then when I get the real answer, I put it back into the website, submit it, and if I'm within the first 100 people to solve it, spoiler, I'm not, because it's already been solved by 100 people because I'm slow. Yeah, you get actual points in the contest. I'm not really competing because the people who can get the top 100 times and actually score points are insanely quick, and I'm not. I'm just doing this for fun. The more turbofish, the better. Both are usable in a const context. Vec default isn't. Here's a style question. Vec_new. I don't know. Vec_new. I think I prefer Vec_new because I don't have to use a macro. So a macro would be something that has an exclamation point for people who don't know Rust. I see a macro as sort of like dirty in the sense that it's not actual Rust syntax. It expands to actual Rust syntax. So it's kind of hiding stuff. Vec_new, using the saying, could be just written as vec macro with empty brackets, right? And it's still the same thing. I'm getting an error here because it just doesn't know the type yet, but that's okay. That's the same thing as doing vec_new, only using a macro. Okay, I must have done undo, so I can't redo that. Anyway, same thing. Oh, that's the turbofish version? You're saying I can do this with vector of somethings, turbofish new. Yeah, that's just, the difference is where you put the type of the argument, right? You either write it like that or I can actually put the type there now, like usize. And actually will compile, right? So you can either do that or you can do it this way. Vec_new, and then put the type here. So those are equivalent. This is the specific syntax to say I want to call new on this type, which is a vector of unsigned integers that can be used as sizes of memory. And this is saying just create a vector. A vector of what? Figure it out. And you figure it out either by the context or by me saying that I needed to hold on to it using a name boundary and limit that name to be, it can only refer to a vector of usizes. I prefer to actually do it this way and let it figure it out. So since it can't figure it out yet, it's like unknown and it's a syntax error. But if I do something like this, push a 0 specifically of U64s, then it's like, oh, you meant vector of U64s. It's called type inference. It's really cool. All right, now that I've lost everybody, let's continue. So we want to just hit every grid location. For y, in this case, I need this, right? Actually, I don't. We can just say let mut I equals 0, and then we can just loop through, when not care about the loop variables, 0 to actually, why not just do it for row in grid, and we're going to borrow that mutably because we're going to be changing it, and then for column in row, right? And then do I need to do that? Do I already have that wrong? Hold on. What is row again? I don't need to put that there because it's redundant, right? Yeah. Okay, that's what it was. Okay, so then actually, I'd rather use numbers rather than characters. So to change the type here, before we collect it into the vector, I'm going to change the characters to numbers by doing a parse to, we can keep it small, like 8 bits, right? And then wrap that in case it's not a number, it'll crash. And what did I do wrong here? Oh, I need to map. I need to put that through map. C.parse. Yeah. Many different ways you could do that, but there's no, you don't use parse. It's just, yeah, never mind. It's C as U8 plus the byte that corresponds to the 0 byte. Actually, I need to subtract, I need to turn that around and do it minus. There we go. So now there are numbers. So for each number, I would say add 1 to it. And then I would say if, no, actually let's turn it around. If column is a 9, then we're going to do a flash, right? Otherwise, we're going to add 1 to it. A flash is that we turn it to a 0 when we increment flashes. And then we add it to the boundary. So I didn't want that to be a vector. Actually, I wanted that to be a hash set, because multiples, I want them to collapse together. A hash set's like a dictionary, or a dictionary with no values. It's just keys. And I need to dereference that. Okay. So boundary, insert X and Y. Oh, actually, okay. I do need the original form of this because I need to know X and Y. So that's for Y in 0 to grid length. Let row equal, grab me a reference to grid Y. Right? And then for the column, similar thing. For X in 0 to row length, let column equal row X. Borrow mutably. There we go. So this will do 1 round, and we'll get boundaries, right? So for those boundaries, then we got a flood fill, I think. It's because the rules say that whenever something flashes, it adds 1 to the energy to all of its adjacent things. This increases energy of all adjacent by 1. So this is what we just did with the for loop, right? We increase the energy of every octopus by 1. Second step is if we get past 9, it flashes, it does 2 things, right? It increases everything else by 1. Hold on, I need to read this carefully. increases the energy level of all adjacent ones by 1, including the ones that are diagonal. This causes an octopus to have an energy level of greater than 90. It also flashes. But if I read this literally, won't that cause it? Oh no, they say it most once per step, right? So yeah, they can't bounce back and forth within the same step. So it is sort of a flood fill then. It's wherever wherever we see a 9, it becomes a 0, and then it goes out adjacent. And if it hits any other 9, those go to 0, and then it goes adjacent, and so on until we stop. Right. And then anyone that flash goes to 0. I'm going to set it to 0 immediately because I'm going to track with the... if it's already a 0, we won't increment it. That's the trick that I'll use here. So we need to do this. While let some xy equal boundary dot next. Well, can I chop one off? I forgot how I did that before. Is it? Let me, not exactly cheating, but going back to where I did the flood fill before. Is it day 9? Yeah. How did I do that loop again? It's the basin area. I did it with iter next unwrap. Okay, so we'll do it the same way. Now I'm lost. Day 11. Yes, so did it with a while not empty. So while not boundary empty. And then same thing here, right? Let point equal, okay, call it border. The last day is, but iterate, just to take an arbitrary one off the list. I need to mark, it is mutable. Oh, that should have been one. Oh, this should be inside this steps loop. They're all equivalent with how the macro is written. You like vec with parentheses, but I was taught with square brackets, so I have to do it the way I was taught. Actually, I just don't really remember that you can do it that way. Rust for FMT always changes it back to square brackets, so it's opinionated then. You can do vec first unwrap, but that one remove the first element. Yeah, actually, this is not a vector, it's a hash set. So I think I do need to iterate and do next, right? Why doesn't it let me do this empty, though? Oh, it is empty. Getting my C++ and my Rust mixed up again. I don't think I need to do this visited, though, because we won't hit the point again because it will be a 0 anyway, right? Yeah, so I don't need to do that part. But I do need to steal from this the list of neighbors. And we're going to paste that here, right? And we're going to increase this to 8 because we're going to include the diagonals too. So let's include the diagonals. -1, -1, 1, 1, 1, -1, and -1, 1. So these are all the 8 neighbors of a given position at 0, 0, right? So like I did on day 9, is I do a for n in neighbors, I calculate that. If it's in range, yeah, I'm just taking advantage of the fact that I already wrote this code. For n in neighbors, get the coordinates. Oh, I didn't get x and y out of that. Oh, because I'm looking at the wrong function. This one. Need that. Why write code when you can steal it from yourself from a previous day? Okay, so yeah, I want that to be not U size, but I want them, well, I guess I can just put it here as I size. I can put it in either place technically, right? We'll just put it there. I guess I did I32. Doesn't matter. Okay, I need the Y range from here. Where to put this? Well, we know it out here. In fact, yeah, we're going to use it in there anyway. We'll calculate it once out here. It's 0 to grid length, and then grid 0 length. So then, yeah, I remember doing this before. I think I had to clone it to use it, right? No, I can just use it. X range. Can't be indexed. Oh, yeah. So as use size. Actually, I'm going to turn that around and make the range... No, keep it I size. Because I want the range to catch negative numbers. So yeah, as use size. Okay. So anyway, if it's in range, then we need to check if it's, yeah, this thing. Only it's not a level, it's let, energy. And it's grid that. If... I should borrow that mutably. If n energy is greater than 0, then if n energy... what am I doing? I should just use a match. What am I doing? Because if it's 0, we don't want to do anything. If it's a 9, if it's a 0 or a 9, we don't want to do anything, right? No, it's just 0 or anything else. Then maybe I don't need a match. If it's 0, we don't want to do anything because it's already flashed. If it's anything else we want to increment, oh right, we do want to have it. If it's a 9, we don't increment. Instead of we do this basically. 9 is essentially this stuff here, comma. Anything else is add 1 to the energy. There we go. And this needs to be x2 and y2. And I don't need to do as I32 because they're already I32s. All right, let's see if I got that right by running the code. No, I have a syntax error. I have a lot of syntax errors. Oh, it's in my encode thing. I need to comment this all out. Shoot. Yeah. I forgot yeah, I need to comment all this junk out. In fact, no, I'm going to just undo that. Can I I can stage it and then undo it. That's what I can do. I can, no, I don't want to stage it. I want to stash it. I wish there was a button to do this here. I need to stash... It's like, see if I can guess the command. It's git stash int code.rs. You can't stash an individual file? Push. Or is it just dash dash? Oh, I need to be in the source directory. There we go. Stashed it. Now I can run the test. Because I don't want to lose that work. I want to get back to it later. Okay, I still have an error up here. Oh, I did have to clone that? Oh, I need to clone it and turn it into an iterator. Yeah, those ranges, they're not copy. I never used I because I ended up just... Oh, I don't know what I was thinking. I didn't need an I. Run that. Okay, so test passed. So I'll just go for it. So cargo run, well, from a directory back, cargo run 11.1. 1700. I have a feeling that I got it wrong. Let's try it anyway. Got it right. On to part 2. It seems like the individual flashes aren't as bright. Start over. Slurring my words. I get a drink from my milkshake, right? Don't I? Thank you, Curtis. Right? Yummy. It seems like the individual flashes aren't bright enough to navigate. However, you might have a better option. The flashes seem to be synchronizing. In the example above, the first time all octopuses flash simultaneously is step 195. Oh, wow. If you can calculate the exact moments when the octopuses will all flash simultaneously, you should be able to navigate through the cavern. What is the first step which they all flash? Well, that's not too hard. So that's taking that answer and putting it here and copying the puzzle. I think we just need to keep going until flashes is 100, or the range max times the range max. So what if we just do that? So we won't go steps, we'll just say loop. And then down here, right, we'll say if flashes equals y range max. How did I get there? I hit the wrong sequence of characters. Max times y range max. Break. And then, actually I need to count the number of, so let, actually I can do it this way, right? I can say for I in 0 unending break I, and then just say that to string. I can't multiply. What is max? Oh, it's an option? Yeah, because they could be unbounded. Is that the idea? And I can't break out of a loop y. Am I not allowed to break out of a for loop? Use break on its own without a value inside of this for loop. Break with value from a for loop can only break with a value inside loop or breakable block. Okay. I thought that might work, but I guess not. So we'll just have to do it the old-fashioned way. Loop, let mute I equals 0. They start from 1, right? So I need to add 1 first. There we go. I have an error. Oh, let's, I guess, can you, wait. It's when I loop, it's, wait, where is it moved? Oh, it was moved outside? Max consumes it? Am I wrong about what max does? What is, yeah, okay, I need to look at, does range have something and just get the max out of it? Wrong link. This one. It's ops range, right? Yes. End is what I know, not max. And I can just use, okay, so let's just end. All right. Let's try this. Something tells me I messed up because it's going forever. What if we have it check here? If does that actually print something? No, it just prints unit. Okay, I did messed up because it should have stopped a lot earlier, right? Well, I could have had my calculation wrong, right? No, it should be synchronized, so I must have screwed something up. If I equals, let's just print out what it is on 194. Print line grid. Well, don't even need to say grid, we'll just print it out. And I don't know, should we just panic at that point? Like, should we just break? We'll break artificially. It'll fail anyway, right? I mean, that looks right. So did I just screw up, oh no, it's not quite right. It's not quite right. Oh, no, it is. It is. So, hold on. And then did I just not get the condition right? So... flashes. Out of that. Maybe I got this wrong and I'm off by one there. Oh, wait. That's the total number of flashes. I didn't want that anymore. That's where I messed up. Flashes is outside here. We need to move it into the loop. That was the mistake. Yes, 100 out of 100. Okay, that was the mistake. Was I need to the part 1 we needed total of all steps. Part 2 we only want a total within one step to see if we got 100. Okay. So just do it with my puzzle input, right? 273. That took entirely too long. I could have had that like a minute or two sooner. Just watch my video on TCP UDP. You like the focus on the functions one would use? Well, I'm glad you liked it. I had a wide variety of responses to those videos. But I'm glad people like it. Thank you, Curtis Wright. How did I do? Probably, if I get between 2,000 and 3,000 rank, I'll be happy. There we go. Actually, we did better comparatively, or there aren't as many people doing day 11. So it's typically taking me 20 to 30 minutes for part 1 and like 30 to 40 minutes to get through to part 2, right? This was day 5 was an exceptionally good day where I got sub 1,000 rank in 15 minutes. And days 1 and 2 don't really count because they're usually really easy. And these days where it's almost 24, that's because I couldn't start on time. This was actually a combination of not starting on time and doing really poorly. And day 10 I also did poorly. But yeah, I'm happy. How many minutes do you think the speed coders did? I'm going to say 1 minute and 54 seconds. Let's see. 4 minutes? Really? Come on, speed coders. 4 minutes? You could have done it faster. Friday night strikes you as a difficult night for people to get on. Yeah, I guess people are out partying. Watching TV, chilling because it's the weekend. What am I doing? I'm coding. That's okay. Yeah, there aren't a whole lot of people doing it. What was my rank again? 2340. So in the time between when I completed it and now, we only got a couple hundred more people. So you can still get under rank 3000 if you solve it right now. It's interesting, when I refresh, the numbers changing slightly as people are actually solving it. That's pretty cool. I can see some people still solving day 8 and day 9. Isn't that neat? Just refresh and see more people solving it. So the drop-off wasn't as steep as it has been in previous years, right? Events, like 2016 stats. Oh, maybe it is. It flattens at a certain point, like around, in this year it was around day 11, where everyone who stayed basically did the rest of them. Well, I guess there's still a bit of a drop-off, but not as steep. Or actually, am I reading this right? I'm not even reading it right. Don't listen to me. There is a continuous drop-off. These days, though, there was the same number. But yeah, there was a secondary drop-off here. So this year's stats, I guess we're still in that drop-off. But there, so the number of people who are actually going to do it is probably around 35,000, right? They just haven't gotten to it yet, or they're going to take longer. Probably just haven't gotten to it yet, because like you're saying, it's Friday night. Day 21, day 10 are the noticeable drop-offs, yeah. C function pointer syntax is odd, but if you read left, inner right, outer left, outer right, it makes sense. Yeah, there was a website that someone told me about. It'll interpret a C pointer as English. Let's see if I can find it again. I thought that was a good idea. Interpret C pointer. It was like an automated site too. Was it Decode? I don't remember what it was now. Anybody remember this? There was like a site. Oh, here it is. C gibberish to English. There we go. Declare X, and you can see it's mostly reading from right. Declare X as a const pointer to const pointer to pointer to char. So we could, like, you know, throw in array or something, and oh, I guess you can't put an array there. But like you can put an array there, and it's like, oh, it's an array of constant pointers to constant pointers to pointers to chars. And then if I put another star in there, const pointer to pointer to const pointer to pointer to char. Yeah, there you go. cduckle.org. It's C gibberish to English. Oh, here we go. I like these examples. Declare foo as a pointer to function void, so a function that takes no arguments, returning a pointer to an array of size 3 of integers. Function pointer syntax? Well, this is a function pointer syntax. Function, it's part of pointer syntax. It's a specific kind of pointer, Musin. C gibberish to English gibberish. No, but this, if you think about a step-by-step reading from left to right, you can follow it along like a logical sequence of steps to get from the variable foo to actually what is it? It's a bunch of integers, right? Assuming you call it, because it's a function in the middle, and you get back the integers. Anyway, what about this one? Oh, this is going the other way. English to C gibberish. Cast foo into block int long returning double. Yeah, block. How do you like that block syntax? That's like a very modern C thing. Anyway, that's what you made me think of when you said pointer syntax is different or weird. Europe still has to wake up. True. And all my EU friends are always mad at me that I do these puzzles at this time of the night, middle of the night for them. Does it decode if there's a function pointer call? I don't know. How would we say that? I guess I take this and I turn it around. Is there a turnaround thing? I can just say this. Oh, no, you said it differently. Function pointer call. So, yeah, this. And then that, right? Oh, I didn't do it right. You have to actually do this, right? Put it in parentheses and put on the right. I think? Maybe not. Maybe it does. Maybe it can't do it. If I simplify that, pointer to function returning int. Let's simplify this as pointer to function returning int. Okay, and then turn that around. So can't I thought I could just... Oh, probably because it's expecting a type, not a variable, right? So that's not exactly gonna work. Oh, was I? No, I don't think so. I just don't... Oh, you're right. Hold on. No, I added it. Added it there. And then added one there. I just can't type. Now I think it just doesn't handle that. It has to be a type. It doesn't interpret an actual call. What if I say call function returning int? Function returning int? Wait, then... Yeah, this syntax is weird. Ah. Does it just handle declare foo as int? Okay. I can't think anymore. Anyway, I'm through with that. It scrambled my brain. Are we done, or should I do a little bit more? I kind of feel like I want to end early because it's Friday night. I need to finish my milkshake anyway. So, oh, I can clean up my code. Forgot to do that. Let's clean it up. This can be cleaned up. I just don't see it yet. Similar to this match. Oh, I don't need... No, I do need this name because I need to use it down here. How'd Copilot do? I don't know. What's the goal for this Advent of Code? It's just like Advent of Code every year. The goal depends on you, but the creator of Advent Code says the most important thing is to have fun the important thing is to learn something. And I guess I would add to that to have fun. So some people will pick up a new language and attempt to solve the puzzles in a new language that they're not as familiar with. Some people just try to speed code this, find the answer as fast as possible. Other people will just be starting whenever and just kind of keeping up with their friends. So like, you know, I could look at the private leaderboard I have with Endurin, right, and see, oh yeah, Maybe we need to bug Endurin because it looks like he's only on day 7. We can help him out when he does 8, 9, and 10 and 11, right? So the goal is sort of up to you. For me, the goal is just to have fun and to exercise programming in Rust because I don't get to do enough of it day to day now. And also because viewers are helping me improve my Rust skills by pointing out things I didn't know. Like as I'm trying to clean this up, I'm sure someone will suggest something and I'll be like, that's a pretty cool idea. Okay. I had to permit the term ugly, Musin. Watch your language. Just kidding. Can you you can destructure the neighbor in that loop using tuple indexing. It's always ugly in your opinion though. Oh, you're saying you think it's ugly that I destructure. Are you saying I could destructure? I don't need the n, right? Because I don't use n anywhere else. So yeah, it would look like x2, y2. Oh no, I need to add. So I need some other name here, like nx, ny. Yeah, I could do that. Yeah, I got it just before you typed it. So that's one thing I could have done. I'm trying to think if I can do this with a match. I think I can. But I don't know if there's a point because there's only 2 cases. I could take the call equal out, but I think this looks kind of ugly. Oh, wait. This would have to turn into that. I think that looks ugly. It does the equivalent though, right? We'd still pass our test. Yeah, it still passes, but I kind of think that looks ugly. So even though the dereferenced column is in there twice, it's fine. This going back between I32 and usize, maybe I can do something about. The problem, reason I'm going to signed math is because when we add the nx and ny, those can be negative because neighbors have negative numbers in there. And I don't want to have to do some kind of weird thing at the boundary of 0 with an unsigned number. So I'd prefer to do signed math and then let the range take care of it. But the consequence is, to use it as an index in a vector, you have to cast it back to usize all the time. So I'm casting back and forth to suit things. Maybe the boundary could be usize. Let me think about that. It's not exactly a flood fill anymore, so do I need to call it boundary? We can say it's, flashed? Why don't we call it flashed? And this should be like, flashes this step. And back here, it's flashed, and then this is total flashes. If I had called it total flashes and flashes this step, I wouldn't have made this mistake of initializing it outside the loop there and then fixing it here after. Match grid slice 0, nothing, and at. Oh, I always forget that at syntax. There we go. So that's teaching me something. At. That's a binding to the value, right? And then or energy. What can I just call it? An energy? It's the same variable. I actually have to go because I have to pick someone up from work. Why did this not... Oh, because I had it backwards. The binding goes on the left. Oh, that binds to the value, not the reference, though. That doesn't quite... Oh, you're... I see. You're just saying I can do that and not dereference it. But I still have the same name, right? So it really is not that much different than what I had before. Is it? I don't know, but I have to go. Yeah, I got the text saying that I need to pick someone up, so let's rate someone else. Oh, Bash Bunny's catching up. There we go. Let's rate Bash Bunny. Or Yes Operator. But we already rated Yes Operator, so let's rate Bash Bunny. Hold on, I need to do this without the audio is looping back. Alright, I hope you enjoyed my take on Advent of Code Day 11. Now over to Bash Bunny, who's catching up on Advent of Code. I think she was on day 2 or 3. See where she is now. But I think I'll see you guys tomorrow, because there's another day tomorrow. Another day, another 2 puzzles. So I'm using saying, just match over the mutable index and introduce the binding when you need it. I'll have to think about that. We'll get back to that, all right? I gotta go. So thank you for watching. Enjoy Bash Bunny. Bye!